Hello everyone again, it's me, and we're going to look at target problem number 5. The T-shaped polygon below can be broken into 5 congruent squares with side length 2. Johnny draws a line segment that lies completely in or on this polygon. What is the maximum possible value of the square of the length of Johnny's segment? Okay, we want the segment to be as long as possible, so kind of my first thought is we could put it in horizontally like this, or we could put it in vertically like this. These are both in those 3x1 boxes. But then that horizontal one, or sorry, the vertical one that is, we can tip over a little bit more, right? We can put it like that, so it's reaching outside the 3x1 box. So that's actually going to be a little bit longer than the other two, and that is indeed the longest segment that is inside this polygon. Now, we have to figure out how long it is. And you might think, all right, it's a right triangle. It's the hypotenuse of a right triangle with height 3, and then base something or other, but I'm not really sure what the base is. So let's start with an easier goal to achieve. Let's figure out the length of this little bit here, which I've marked off with red. And this triangle has a base of 2, a height of 4. So its hypotenuse by the Pythagorean theorem is the square root of 2 squared plus 4 squared, which is the square root of 20. Okay, but what we actually want is this whole line. Now, the height of this whole polygon is 2 plus 4, which is 6, right? So this whole height is 6. This means that if we scale up by a factor of 6 over 4, we're going to get the length of the whole segment, right? This bit has height 4, this bit has height 6. So we are dividing by 4 and multiplying by 6. Now the square root of 20 times 6/4. What we want to do here is remember that we're looking for the square of the length of the segment, not just the length of the segment. So we may as well square this before we mess around too much with it. Although we'll simplify 6/4 is 3/2. So 20 times 9/4. Square root of 20 squared is 20. Square root of 3/2, or 3/2 squared is 9/4. 20 times 9/4 is 5 times 9, which is 45. So that is the maximum possible value of the square of the length of Johnny's segment. And that is the answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.